Okay, so we left off with identifying mineral number 15 as limonite, and now I want to show you how we're going to fill out the data table. So this is mineral number 17. So the luster was metallic, we determined that right away. And the hardness, now that we know that it's limonite, we can actually go back and look. It is about a 6 on Mohs hardness scale. I would describe the color as brown and the streak as yellow-brown. Really, you can describe them how you feel like you would recognize them in the future. So not everyone's brown or yellow-brown is the same. So even if you look at the data tables and you see how they're described there, this could be a little bit different. You might decide to have a different description. There is no cleavage in this mineral, so we're going to say fracture. And we don't really have any particular other property. The mineral is limonite. And it is an iron ore. So the economic use of this particular mineral is for the iron. So let's go on to group 2. Let's assume that we have a non-metallic mineral that's dark colored. So we're starting on the left, and the mineral I'm going to choose to look at is number 4. Now I've added a second sample of number 4 here because I think here you can see a cleavage face quite well. This entire face here and here, there's a little step between them. They're all reflecting light. So there is cleavage in this mineral. It isn't that easy to see. I'm jumping ahead because the first thing we want to know is the hardness of the mineral. Is it harder than glass? Is it softer than glass but harder than a fingernail? Or is it softer than a fingernail? And it turns out that it is harder than glass. It isn't necessarily harder than quartz, which is a 7 if you recall, but it is harder than glass. So now we want to know if there's cleavage present. And I've just mentioned to you that indeed, difficult to see, but there is cleavage present. And so now we're down to 3 different minerals. We have something called augite, which is greenish black to black in color. Hornblende, which is black to greenish black in color, which is kind of funny because what exactly is the difference? And then we have plagioclase feldspar, which is white to gray. And this definitely does not look white to gray to me. This definitely looks like it's in the blacker region. So I would start to narrow in on these two. Now, both of these minerals, augite and hornblende, have the same hardness. They have roughly the same specific gravity. And they have fair cleavage. Fair cleavage means that the cleavage is not really well pronounced. This is an excellent example of fair cleavage, not excellent cleavage. But the key difference between these two minerals is that augite has 2 cleavage directions at about 90 degrees from each other, whereas hornblende has 2 cleavage directions at 60 and 120 degrees from each other. And I know it's very difficult to tell in this sample, but as I mentioned in the video, this is a 90-degree cleavage angle. So this mineral is actually augite. And I put the streak plate here. I tried to streak it. I didn't get a streak. They didn't really even mention the streak here, but there was no discernible streak. So now we go to our mineral data sheet, and now I'm back to the first one because this is sample number 4. So we have a non-metallic luster. The hardness is between 5 and 6. I would call the color of the mineral black. You might call it greenish black. And the streak was colorless. So even though it's a black mineral, the streak is not black. There were 2 cleavage directions at 90 degrees from each other. And don't worry if you don't see this. This is a very difficult thing to understand as a new geology student. So you're going to have to just kind of trust me on that. Not really any special other properties, and the name we're going to come up with is augite. Now, augite doesn't really have an economic use. It's a rock-forming mineral. It's very common in certain rock types. And so the reason it's in this lab is not because we use it economically, but because we're going to be coming across this mineral quite a bit next week when we look at rocks. Let's move on to the third group, non-metallic and light-colored. So I'm going to use sample number 3 for this one. And again, it's non-metallic and light-colored. And the first thing we need to do is determine its hardness. So if I scratch this mineral on quartz, it does not scratch quartz, but it turns out that it does scratch glass. So it's actually up here in this category here. And then we have cleavage present or absent. Well, this mineral, if you watch the video, has two directions of cleavage that are about 90 degrees from each other, so cleavage is definitely present. And this brings us down to the two feldspars. And the two feldspars really are often difficult to tell from each other. One thing that would be unique would be if this was pink. Because if this was a pink feldspar, it would definitely be this one up top, potassium feldspar, which is pink or white. Plagioclase feldspar is white to dark gray. So if you have a whitish, grayish feldspar like this one, you don't really know which one it is yet. But if it were pink, you would immediately know it has to be this one. Okay, so we have hardnesses of 6, we have specific gravities of 2.6, we have two directions of cleavage at nearly right angles. So really everything is very similar, except this last bit. Potassium feldspar does not have striations. It actually has a texture called a perthite texture that looks kind of like the marbling in meat. It's not real linear, but it is a fabric that has a certain orientation. Plagioclase feldspar, on the other hand, has something called striations. And these are very, very linear, very straight, very tiny, very close together patterns on one of the cleavage faces. So this one, I can see it a little bit in this direction that I'm pointing, but I have another piece here that has very, very clear striations. And so you can see them. Here's some lines to help your eye see the direction of those striations. You also can see some down here. If I take those away, you can still see the direction of these striations. So that tells us that this mineral is actually the plagioclase feldspar. So we go back to our mineral data sheet and we fill out number 3, non-metallic luster. It has a hardness of 6. I would call the color light gray, and the streak I didn't show you, but the streak is pretty colorless. It does also have two cleavage planes at 90-degree angles. And in this case, we might put something in the other property. We might mention those striations because they're very distinct in this mineral. They're not common in a lot of minerals. We give the name of plagioclase feldspar, and we're again going to call this a rock-forming mineral. It's very common in rocks. It isn't used much in industry, a little bit in ceramics and jewelry, but mostly it's a rock-forming mineral. So this is your lab assignment. You have 18 minerals to identify. There's 18 videos to watch. The 3 that have check marks we just did together. Remember that the key is to look at these charts that will help you. I'm going to make it a little bit easier on you and tell you exactly which minerals you have to choose from. So of the ones that are in group 1, you have magnetite, pyrite, hematite, galena, limonite, and native copper. And we've already identified the limonite. So you've got these other 5 in the metallic group. In the non-metallic dark-colored mineral group, we have augite, which we just identified, and hornblende. We have olivine, which is green but still considered a dark color. And we have biotite mica, a black mica. Remember, the micas are those really thin sheets. You'll notice that there are some things here that seem to be a repeat from group 1. We've got copper, hematite, limonite. Don't worry about that. The problem is these minerals happen in different forms sometimes. Nature is not always perfect. And they're listed here because sometimes that might be the type of sample you get. But we're not going to worry about that. We're just going to go with what I've called metallic. Finally, in the third group, we have all of these here: potassium feldspar, plagioclase feldspar, which we just identified, quartz, calcite, and halite. We then have muscovite, mica, like biotite but light colored, and gypsum. And I've tried to highlight here because there are 3 varieties listed here: selenite, satin spar, and alabaster. And satin spar is the one that you have in your mineral kit, and if you can read it, it says fibrous, silky luster. So it looks like fibers. Oh, and then we also have sulfur. Finally, the last bit to do is the lab report. This is quite important because it's a good summary of everything you've learned. All of the problems are assigned, but I did circle in green the problems that I really want you to focus on. These are the ones that will really show me that you've learned what I want you to learn about minerals. And number 11 especially is the type of question you might see on the final exam or a quiz. Using those 3 classification pages, if I give you this detail right here, can you follow those flowcharts and figure out the name of the mineral? It's a busy lab. There's lots to do. There's lots to learn. But it's important that you master this before we move on to rocks.